Students, here we start second lecture of solid state. Properties of four types of crystalline solid in a tablet form and crystal structure we will going to see. Properties of four types of crystalline solid with respect to properties as follows: particles of unit cell, interparticle forces, hardness, melting points, thermal and electrical conductivity, and examples. So here is a table that you can refer from the textbook also. Our next topic is crystal structures. The ordered three-dimensional arrangement of particles in a crystal is described using two terms, namely lattice and basis. So what is crystal, lattice and basis, that we will see. Lattice is a geometrical arrangement of points in a three-dimensional periodic array. A crystal structure is obtained by attaching a constituent particle to each of the lattice points. Such constituent particles that are attached to the lattice points form the basis of the crystal lattice. Crystal lattice is also called space lattice of the crystal. Thus, crystal is the structure that results by attaching a basis to each of the lattice points. It is represented by the following equation: lattice plus basis is equal to crystal. So that we will see clearly from the figure. Now we will see what is unit cell. The space lattice of a crystal is built up of three-dimensional basic pattern. This basic pattern is repeated in a three dimension to generate the entire crystal. The smallest repeating structural unit of a crystalline solid is called unit cell. When the unit cells are stacked together to generate the crystal, each unit cell shares its faces, edges, and corners with neighboring unit cells. It is important to understand that the geometric shape of a unit cell is same as that of the macroscopic crystal. For example, if the crystal has cubic shape, the unit cell will also have its constituent particles arranged to form a tiny cube. The dimensions of a unit cell along the three axes are denoted by the symbols A, B, and C. The angles between these axes are represented by the symbol alpha, beta, and gamma respectively, as shown in figure as follows. In this cubic unit cell, A, B, C, and alpha, beta, gamma are named according to anticlockwise direction. Now, type of unit cell. There are four types of unit cell. First one, primitive or simple unit cell. In primitive unit cell, the constituent particles are present at its corners only. Second, body-centered unit cell. In this type of unit cell, one constituent particle is present at the center of its body in addition to the corner particles. Third, face-centered unit cell. This unit cell consists of particles at the center of each of the faces in addition to the corner particles. Fourth one, base-centered unit cell. This unit cell consists of particles at the center of any two of its opposite faces in addition to the corner particles. Next topic is crystal systems. By mathematical analysis, it has been proved that only 14 different kinds of space lattices are possible. In other words, there are only 14 ways in which similar points can be arranged in a three-dimensional order. These 14 lattices, which describe the crystal structure, are called Revised lattices. 14 Bravais lattices are divided into 7 crystal systems. The possible combinations of lattice point spacings, that is A, B and C, along 3 axes, and the angles, that is alpha, beta and gamma, between these axes given rise to 7 crystal systems. In other words, 7 crystal systems are associated with 14 Bravais lattices, also called 14 unit cells. The 7 crystal systems are named as cubic, tetragonal, orthorhombic, rhombohedral, monoclinic, triclinic, and hexagonal system. Cubic system will be discussed in the following section. Cubic system. There are 3 kinds of unit cells in cubic system: primitive or simple cubic, body-centered cubic, and face-centered cubic, which are abbreviated as SC, BCC, and FCC respectively. First, simple cubic unit cell, that is SC, has a particle at each of the 8 corners of a cube. Second, body-centered cubic unit cell, that is BCC, has particles at its corners and an additional particle in the center of the cube. Third, face-centered cubic unit cell, that is FCC, has particles at the center of each of the 6 faces in addition to the particles at 8 corners of the cube. Next is number of particles in cubic unit cell that help you in numerical. First, primitive or simple cubic unit cell, that is SC. A simple cubic unit cell has particle at its 8 corners. When these unit cells are stacked together, particle at each corner of the given unit cell is shared with 7 other neighboring cubes that come together at that corner. As a result, the corner particle contribute its 1/8 part of the given unit cell. Thus, a simple cubic cell has 1 by 8 into 8 is equal to 1 particle per unit cell. So, arrangement of particles can be clearly seen from the figure following. Uh, First one is the arrangement of constituent particle. Secondly, it occupies at 8 corners, and third one is the sectional view of particles in a cube. Second, body-centered cubic unit cell, that is BCC. A BCC unit cell has 8 corner particles and an additional particle at the center of the cube. 1/8 of each particle from 8 corners belong to the given unit cell as mentioned in simple cubic unit cell. The particle at the center of given cube is not shared by any other cube. Hence, it belongs entirely to the given unit cell. Thus, BCC unit cell has one particle from 8 corners plus one particle in the center of the cube, making total of 2 particles per BCC unit cell. The arrangement of constituent particles can be clearly seen from the figure as follows. First, the arrangement of constituent particles. Secondly, we will see the particles occupied at the corner of cube and one additional particle which occupy the center of the cube, and the sectional view of these can be clearly seen from the third figure. Third, face-centered cubic unit cell, that is FCC. A FCC unit cell has particles at the 8 corners plus particle at the center of its 6 faces. As described in simple cubic unit cell, one particle from 8 corners belongs to the given unit cell. Each particle at the center of the 6 faces is shared with one neighboring cube. Thus, 1 by 2, that is half of each face particle belongs to the given unit cell. From 6 faces, 1 by 2 into 6 equal to 3 particles belong to the given unit cell. Therefore, FCC unit cell has 1 corner particle plus 3 face particles, total 4 particles per unit cell. Arrangement of constituent particles can be clearly seen from pictorial presentation. In first figure, as usual, there is arrangement of constituent particle. In second one, the 8 particles are occupied at 8 corner of the cube and 6 particles occupied the center of the faces. And third figure, we will see the sectional view of these particles in a cubic unit cell. Pictorial presentation of all the remaining crystal systems can be tabulated in a following table that you can refer from the textbook also.